Okay, so I'm gonna go over the multiple choice tomorrow. I will finish the other part. So here they're asking you from questions 1 through 25 are multiple choice. So this is very easy. Reject a null hypothesis when it's true. That's a type 1 error. You know that. Failing to reject the null hypothesis when it's false. That's a type 2 error. A parameter is a characteristic of the population, right? Statistic is a characteristic of the sample. When the correlation coefficient R is close to 1, that means that there's a strong linear relationship, right? Strong relationship, linear relationship between the two variables, okay? So here they want you to find the regression equation. You don't need to do this by hand. I'll show you right now how to do this in the computer. And it will, when you're doing your calculator, you should take maybe 2 minutes to do it, or maybe less than that. Let me share this with you. Okay, so you can do this, and let me make it bigger. Let me clear this up, and you need to write these numbers here, right? So stats, enter, and you go here, clear, and now you write your data. Input your data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then in L2 you type 1.24, 5.23, 7.24, 7.60, 9.97, 14.31, 13.99, 14.88, 18.04, and 20.70, right? And check your input first before you hit enter, because you might make a mistake. So 1.24, 5.23, 7.4, 7.24, 7.60, 9.87, 14.81, 13.99, 14.88, 14.88, 18.04, 20.7, and that's it. And then the other one is 1, 2, 3. So you press go to stats, go to calculation, go to regression, or number 8, click here, enter, 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 enter. So here I don't have the regression equation. I mean, I have the regression equation, but it doesn't give me R and R square. But if you press in your calculator, you should get these values, okay? It's just in this thing, doesn't give me the values. So you go to, so your equation should be, let me go back to the slide. Okay, so let me go back to my presentation. So this is y bar. Y bar is a plus bx, right? So y hat equals, we didn't have this data here. 1.24, yeah, I have that. So I get, sorry, let's see. So I have, okay. So my A is 0.436 and my B is 1.97, or yes, 1.97, and you say 1.978. So that's it. That's my equation. So you can see clearly that this is this one, right? So Okay, so this is answer. So you can just do that in the calculator as I show you. And now use the data to calculate R. If you have your calculator, it will give you R in your calculator. If for some reason it doesn't give you R, just let me know on the test, okay? But if you do that, it will tell you that R is 0.985. So this is answer. And the coefficient of determination is just R squared. So if you square this value, you get 0.9705. So it's strong, right? Because this value R squared ranges from 0 to 1. Okay. Okay, using the data from problem 6, I meant obtain a predictor of 45. So you have to use this equation right here, the linear regression, right? So let's copy that and just plug 45 here, right? That's it. So y bar equals 0.436 plus 1.98 times 45. If you plug that in your calculator, you get your answer, right? So 1.98 times 45. 1.98 times 45. Oh, this is 4.5. I'm sorry. This is 4.5. So 4.5 times 1.98 plus 0.436, you get 9.346. So this is answer. So here they're asking you the below data in the scatter plot should be below, right? Will have a correlation coefficient that is close to, you can see that there's a strong negative relationship here, right? So that's going to be a strong negative relationship. So that's going to be -1, right? The intercept in linear regression, the strength in linear regression between X and Y, no. The expected value when Y equals 0, no. The expected value, the expected Y value when X equals 0, yes, that's a y-intercept, right? When X equals 0, you get the y-intercept value, right? The histogram below is the lifespan of a random sample of a particular insect. Determine the relationship between the mean and the median. So you can see clearly that this is skewed to the right. So that means the median is more robust, right? The median should be more robust than the mean. So the mean should be to the right, right? Therefore, because this value is to the right, right? The mean is gonna be greater in value here. So we can say that the mean is greater than the median. So this is the answer, okay? So think about like this is 5 and this is 7, right? In the number line in X, in the in the X line, right? Like these things, like here. So if you are at 5 and this is 7, right? This number, whatever is to the right, should be larger, right? That's what I meant. Okay. So here this is a numerical value whose value can change from one replicate of the experiment to another. That's a random value, right? That's a random value. Okay. So the relationship between the number of miles driven and the amount of gasoline. I made a mistake here. I meant to write this thing, right? So the relationship between the number of miles driven and the amount of gasoline. So it's also it's correlated and causal, right? It is both the causation and correlated. There's a correlation and causation, right? Because the more miles that you drive, the more gas you will spend. So it's both correlated and causal in this case, right? In a random sample of 1,000 students, the p hat, right? The sample proportion is 0.80, where in favor of longer hours at the school library. The standard error of p sample proportion is, so this is basically only p hat, q hat, square root of that, n. That's the sample proportion or the standard error for the p, right? You say error if you want here. So this is p hat, so this is 0.0, 0.20, and this is n is 1000. Take the square root of that and multiply those numbers, right? So 0.80 times 0.20 divided by 1000, you're gonna get something very small. Take the square root of that and you get 0.126. So that's this answer, right? Actually, I'm sorry, this is 0.0126. So it's the first one, okay? The null and alternative hypotheses are a statement about the population parameters, right? I don't even need to think about that. A result is statistically significant whenever the p-value is less or equal to the significance level, right? We talk about that. The p-value has to be less than alpha, right? Less or equal than alpha. So usually 0.05. So you want your p-value to be less than that, right? To be statistically significant, right? Okay. The confidence level for a confidence interval for a mean is the probability the procedure provides an interval that covers the sample mean, the probability of type 1, no, probability the individuals. So this is the D, right? The probability of the procedure provides an interval that covers the population mean. That's what is the confidence level, right? Okay, that's what they're asking, the confidence level for a confidence interval for a mean, okay? The value of the coefficient of determination R squared. I just explained that before, is between 0 and 1, right? If comparing R equals 0.8 and R in one study and R 0.4 in another study, which of the following is the best choice? 0.8 is twice as good. That's wrong. 0.4 is better because it's less. That doesn't make any sense. When R equals 0.8, then 100 times 0.8 squared is 64% of the variation of Y is accounted to the relationship with X. And when R equals 0.4, 100 times 0.4 to the second power is 16% of the variation of Y is accounted by the relationship with X. Thus, the sense of percentage of variation account for, we can say that 0.8 correlation is 4 times as strong. Absolutely, right? It's 4 times as strong. So you can see 16%, 64%. So this is the answer. Okay, so I'm gonna stop here. Tomorrow I will do part 2, the computation, right? Part 3 and the rest. Have a good night and please keep reviewing and keep studying. Thank you.